Right. Very exciting to see so many faces after the party yesterday. I would have expected to speak to Phil and have a private talk, but all right, whatever. So yeah, I'm Martin. I work and help the team and do weird shit at Archaeologic, which is a company that does a 3D editor and kind of a 3D viewer in the browser. It works on your phone, it works on your computer, it works on your fridge, I don't know. If you're going on the page with a Nokia 3310, it might not work that great, but we're trying our best. And as Phil said, doing 3D and VR in the browser is cool and fun and games and all, but it's called bleeding edge for a reason, right? Because you cut yourself. And then you bleed. And so actually I had to spend a lot of time digging into performance and how browsers render things and how computer graphics generally work. And I find that we have a lot of resources here as the web development community that allow us to figure out how to render things efficiently in the browser. Nonetheless, they all stop at a certain point and go and this is good and this is bad. But no one really digs into the why. So first things first, why should you even care about web rendering performance? And I think two factors that I really think are important. It's not a kind of puzzle or a kind of race to oh, my development skills are better than others. No, it is about your users. Because if your website is badly performing and is actually sluggish and I click on things and then I have to wait for things to happen and all that kind of stuff, it steals users' time. And users are using your product to get something done, not to stare at really badly made animations, okay? And that's why Val Had's talk was so important. You have to start thinking about animations early on and then kind of, go through with them rather than just smack them on at the end and yeah, it's not performing that well, but it's fine. It's not fine because, users really want to get on with their lives and we should get out of the way of our users. And also emotions. I mean, who here gets frustrated if they are seeing a super sluggish website or click on a thing and nothing happens for 10 seconds or something? It's it pisses me off, which I'm sorry for my French. So yeah, make people happy with your things, but make things that are enjoyable and fast. And I think that's really, really important. Performance is not a self-sufficient thing. It's a means to an end, and that's making users happy by getting out of their way, in my opinion. All right. So today I'd like to kind of dig in a little deeper than most resources do, and we're going to kind of, it says inside out, because we're going to start at the other end of the spectrum. We're starting with computer graphics, which usually is taught in universities for half a year at least, if not longer. But I have 30 minutes, that's going to be fine. And then we're going to talk about how browsers in particular render things, because that's a little different from miscellaneous computer graphics. OK, so let's start with computer graphics. I really thought about finding a image that shows the pipeline from the beginning to end of how that actually computers render things, how computers make screens light up. And there's terrible things with at least 48 boxes in 7 different colors, which all have meaning. So I thought I'd make it simple. And then I came up with this illustration. And I'm yes, slide done. And then I went over the slide again, and I'm maybe not, right? Because what are these layers? What the hell is that? And then it goes into a shader, what? And then what? Right? It's magic happens, and then pixels show up on my screen. So that maybe is not the best start. So I thought, how about we start differently? We start at the pixel level, right? Because pixels are the smallest unit that we have. And I put them in, and then magic happens on the screen. Just like that. You have no idea how long it took me to hand make this GIF, OK? So don't judge me on showing it a few times. So we're starting at pixels. But what are pixels actually? I mean, yes, sure, it's the smallest thing that a screen can display. But what does it really mean? Well, a pixel is technically a small box that we can color in by making 3 little tinier dots on our screens light up. And each of these can light up in one of 3 different colors. We have a tiny little red dot, we have a tiny little green dot, and we have a tiny little blue dot. And when all of them light up at full intensity, we see white. If they are all turned off, we see black. So for this color here, we have 100% intensity for red, 66% intensity for green, and 33% intensity of the blue light shining up. And that gives us this I think, pleasant orange color, but I've been talking about colors with other people yesterday, and apparently whenever I find a color pleasant, everyone else hates it, so fight me. So what we're having here is like 3 numbers, and those are percentages. But percentages are not something that computers inherently are good with. But computers actually deal with bits and bytes, right? So if we have a byte, then we can store 256 values in them. Values from 0 to 255, for instance. And now we have to like kind of map that to the 0 to 100% intensity of the colors. So we pick a number between 0 and 255. 255 means that little tiny colored dot is full on and bright as can be, and 0 means it's off. And there's another notation that you might be used from CSS. The hex notation is the same thing. It's just a hexadecimal representation of the same number. Because it's convenient to use hexadecimal, as 2 digits in hexadecimal are exactly 1 byte. So here we see like FF is the full-on red, AA is the 170 or 66% green, and 55 in hex is 85 in decimal or 33% blue lighting up. So what this is from the abstract concept of tiny little dots lighting up, we go to a bunch of numbers. Technically, we go to a bunch of bytes, really. So we know how to store bytes, right? If you've ever, who here has ever used an array? That's very good. Who here has ever used a string? Amazing. A few people are like, what is this? What university have I been transported into? So if we want to store bytes or values in a computer, all we need to do is, we list them out, and that's it. We're done. That's all we have to do. And that's really cool, because this is, for instance, this is 3 numbers, my 3 numbers, so it's 9 numbers, and we can think of this as 3 pixels. This is probably the lowest resolution I've ever worked with, but that's OK. We can work with that. So if we want to make things appear on screen, colors appear on screen, we just write numbers in. So here I wrote the red part to be full intensity. We have a red pixel now. And then we put another full-on green here by putting this other 255 in. And then last but not least, we get blue. And then we can write random numbers everywhere, and then we get colors on screen. That's rendering. That's all it is. Mind blown. It's simple stuff, right? Well, it's not as simple. One good thing that we can see here is that the pixels are independent of each other because they're not overlapping in memory. So that means, theoretically, we're not having like write conflicts, or we have to make sure that we're not like, right, like, oh, if I write this first and then this second, then I have a problem because I'm having like writing at the same position in the array, and you never know what comes out of it. We don't have these problems because they are separate from each other. But unfortunately, it's not always easy. So here we have 2 pixels on the top left-hand corner in red, and we want to move them 1 pixel to the right and 1 pixel downwards. But we can't just write these new values in here, because we have to also reset the old values. If we wouldn't do that, then we would basically start to draw a line at some point if we continue to do that. So we have to keep track of where does the thing come from and where does the thing go to, and then you have to kind of deal with that logic. Unless you don't want to deal with that logic, because there's tricks that allow us to not do it. And these are called sprites. Who here has heard the term sprites before? Who here knows what it is? Nah. Don't worry. There's 3 terminologies depending on who you talk to. CSS people might know the term sprite. Whoever has dealt a little more with rendering in browsers may have heard the term layer. And people who come from a 2D or 3D graphics background, you might have heard the term texture. They're all the same thing. It's just cheating at Scrabble. You don't know which kind of letters you get, so you kind of get more words that you can use for the same concept, really. But it's the same concept. And the concept is, you're basically just taking them out of the screen memory. So you have an array here that is the screen, and then just make a new array over here where you put your images in. And then it's much, much easier, because you just go like, I copy the entire freaking array into this other array here, which is my screen. And here we have 2 sprites. We have a background, and we have the Nyan Cat. Now, the Nyan Cat is a bit tricky, because here we have transparency. So how the hell does transparency work? Well, it's just another number, really. Just add a 4th number So we have red, green, blue, and then we have a number that goes from 0 to 255 that tells, is this transparent, or is it like half transparent, or is it not transparent at all? And that's kind of how we express that. And now we have these two different arrays. You know, remember, the pixels are just a bunch of numbers in an array. So we have these two arrays, and then we have a third array, which is our screen. Now, if we want to draw, the first thing is we read from the first array and just put everything in that array onto the screen. So we copy the entire array over, and we are done. And then we go for the next one and figure out, like, we want to start here, and we copy the entire array there into the other array that is on screen. And that's all that rendering really is. And then when you want to move things, then you just, do the first thing again, just get everything back to the start, and then put the new thing again on a different position. And if you do that often enough, then it goes yan 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 and stuff, And that's what rendering is about. And if you do this right, and you're not doing it wrong, then you definitely get a good performance, because computers are really, really fast at copying memory over. So you hopefully get at least 60 frames per second. I mean, that's also the maximum that the browser gives you, but other platforms might give you more. And this kind of process of putting things on top of each other has a name. And that name is compositing, or composition, or composite. So this is what compositing is about. Quickly copying memory over each other. Now, how exactly does that work, though? So compositing is basically a function. It gets two inputs. It gets the screen memory as it was before, which is where it also goes to, so it's called destination. It's weird, it's an input, but it's the destination, it's where it goes to. And then we have the source, which is the sprite that we want to composite on top of it, we want to draw on top of it. And then it gives you the new screen memory, like this new array of pixels after the composition. And that's the input to the next round of compositing. So that's kind of like a loop here, right? And how does that exactly work? I mean, OK, cool. We have one array of pixels. And we have another array of pixels. And then magic and things on screen. What? Right? What's this question mark doing over there? I don't like question marks on slides. So let's answer the question. So for instance, what we could do is we could go, so I want to draw, oh, I don't have a laser pointer on this wonderful thing. I want to draw, this is hilarious. I'm using virtual reality so that I don't have to walk, but fine. So we want to draw this point here, for instance. Well, how do we do that? Well, we check it out by going, is there a point, is there a color in this array here? Yes. All right, we just use that, done. If not, then we use whatever we had before, and beforehand we have drawn this one, so we just pick a point here, and then it's going to be fine. So we just basically do an OR combination of them. We say, like, do we have something in the Nyan Cat? No. Or is it transparent? Oh, it's transparent. So in that case, we just use whatever we have already on screen, which is the background. But no one says that you have to do that. Like, it's not like a natural law of physics. So we can break it and just go like, no, you know what? I'm going to multiply the colors. Right? So we basically scale them to a factor, like 255 would be 1, 0 would be, well, 0, and everything else in between is a value in between. And then we go like, OK, so this is the eye is white, so the little glare in the eye is white. That's 1.0. And then we have the blue color of the background, so it's 1.0 that color, so the color doesn't change. But then there's like the rest of the eye is black. So we're using whatever color the background is times 0, which is black. And everything in between looks like this. This is called multiply, surprisingly, because we're multiplying the different layers. But there's other equations available as well. And they go by the name of blend functions. So this is the blending that Una was mentioning, no, not yesterday, the day before yesterday, when she said, oh, blend modes are amazing. Blending is nothing else than the equation that we are using to figure out what we're going to put on screen, like how we combine the different layers. That's all it is. And there's a bunch of them, and they all look funny. I mean, this one is a bit boring, right? The middle one, for the second from the left. But it's an interesting thing, and you can play around with it. And theoretically, if you would be writing WebGL or OpenGL code, you could write your own blending function. And they usually look like something like this. So this is the screen blending mode. And here we have like the color at position X, Y on the screen is, whoops. Oh, great. We have our daily hangout soon. That's amazing. That's why you close other browser windows. That's some live coding demo. That's cool. Whatever. So we are back. We are back to screen. There was something on the screen, but now we are back to blending with the screen mode. So here we have our two things blended, and they are blended by the color at the position x and y is 1 minus whatever color we have in the cat picture, multiplied by 1 minus the sky color at the position that we are trying to blend on. Complicated, but you don't have to do it. You just go like CSS, mix blend mode, screen. So that hides away the complexity. And there's like no natural law about this. It was like literally a random person going, that looks funny. I like that. I call it screen. All right? So that's how these were made. Probably that's historically inaccurate, but go with me here. It's early in the morning. There's other things that compositing can do, because basically what we can do is we can also add offsets to where we are drawing things to. So now we can say, actually, I want to move this over to the right and maybe to the bottom, or I don't know, move it to the left and move it a little up. So we just add where we are looking up the things from, like where do the colors come from that we're going to put in a different position. That's called translation. It's just like moving things around. You can do the same thing with scaling. You just multiply your source with a factor. And then the pixel shows up, like the lookup in the pixels happens twice, and then you have 2 pixels instead of 1 pixel in the original image. So scaling is another composite-only thing. Also, there's rotations, but that involves matrix multiplication, and it's a pretty early talk, so I just have the slide here, but let's move on, OK? Just because there is going to be men on the internet going, but actually you should have shown what and I'm like, no, I'm not going to do that. Move on. Write a wiki article or so, made a medium think piece, whatever. I get a laugh for that. OK, that hit home. So yeah, we have rotate, translate, scale as a composite-only action. We have blending that is composite-only, and then we have also filters, which is kind of like blending, but you do it like after you have combined everything else, like you run it the last thing over. However, this being the web platform, things are not that easy. So blending and filtering only is composite only if it's on a separate layer. So if it's in a sprite, if it's part of the larger thing, if it's like just in the body somewhere, then it doesn't the browser doesn't know how to composite it, so it's gonna redraw, right? So it has to repaint everything. The same goes for filters, and also filters I'm really looking forward to the web compat talk from Ola later, because we really need more people looking into that, because there's web compatibility issues. So we're going to explore filters a bit more in detail. But before we do that, there's a warning that this is basically constantly changing how browsers do these things. So this slide, the following couple of slides, might actually become outdated at some point. So always measure and check. This knowledge might outdate. And to make sure that you don't forget that, I have my friend Bob over there sitting on the slides watching over me chatting about things. So these are like the filters that we can do. And a few of them are basically more or less obviously compositing, if you think about it long enough. For instance, grayscale. All you do is instead of taking the colors from your sprites, you just average red, green, and blue, and then kind of divide by 3, and then use that for all of them, and then you have like a grayscale image that you don't have to repaint things, because you just change the input to the calculation you do in your composite step. Others, like blur, are not that obvious, but they work as well. And so that means that these are composite only. The browser does not repaint pixels for them. That's really nice. However, did you see something? Do you know what this means, this graphic? So we have one CSS filter, and one is the SVG filter. Both are the blur filters. And the bluish lines around them means they are on a separate layer in the browser. So they are sprites. However, when the filter kicks in, there's a green flash over the blue SVG circle. And that means, this green flash means the browser has repainted these pixels. Like the browser did not just composite, it actually went over and redid all the pixels. So same filter, however, in SVG, they repaint. And repainting takes longer than compositing, because compositing is just like I run an equation in parallel for all the pixels, versus I have to make the pixels all one by one. Drop shadow is also one that it exists as a filter. However, unfortunately, Safari has a bit of a problem there. You see that down here. Oops, down here, the red dashes here. That's paints. So it has repainted a few times. That drains your battery. That makes it sloppy. Do not do that. So compositing really, and this is where like the word shader comes in again. The shader is not it's just a function that takes a bunch of inputs. It takes the x coordinate, the y coordinate that we want to put it onto the screen on, and it takes the array of different arrays with pixels that we kind of read from, and then we have a blend function and the filter function, and we just call the blend function on the sprites, and finally we run the filter function, and then we get a color. That's all a shader really does. At least the fragment shader. We're not going to go into 3D graphics. Ignore that for a second. So now we kind of have like all the terminologies together. We have a bunch of numbers, and then we have this composite function, and then more numbers come out. And these numbers show up in colors on your screen. Is that better? Better than before? No? Yes? Maybe? I like chocolate? I don't know. So let's recap quickly. So pixels are basically just a bunch of numbers in memory, and they are really useful because we can separate them into different arrays and then just like do things by just combining and copying arrays over. And the cool thing is that this compositing is basically just like copying things, and that's really fast, and we can run a function on how we copy things, so that's really nice. We get a few things, and also how we combine can be determined by figuring out what kind of blend mode we are using. That gives us a bit of flexibility in our art direction as well. And it can be done concurrently, because it's just like, I take this thing from array A, I take this thing from array B, and like I run this function over the two values, and voila, we have it on the other array. It's never going to be like, if this pixel here is blue, then this pixel here is going to be red. So it's no dependencies between the pixels. So we can do that in parallel. And graphic cards do these operations in thousands in the same time. So that's really, really fast, because we have to draw tons of pixels. Now let's look at browser rendering. With these wonderful illustrations from a co-worker of mine, David Tran, Pandatology on Twitter. Highly recommend following him. He's trying to start a religion on like believing in pandas. I think that's like worth joining. Anyway, so basically the browser at some point comes from, or the server comes from the network and goes, here is a bunch of text. Let this be your manifest of making things happen on screen. And then the browser goes, so here's a headline that like is 25-point size, and then here we have, and it kind of like has to arrange them and figure out how large things are and what kind of content there is. And then once it has figured out how large things are and what the content looks like, it's going to start painting, which is brilliantly illustrated by making unicorns, chiseling them into stone. And then once we have all these building blocks together, we can then put them together by compositing them to the full page. Boringly enough, that's also like called style, layout, paint, and composite, but you know, just for sake of completeness. So when we want to make things performant, the best thing we can do is we can avoid doing things. Like a thing that we don't have to do is always the fastest way of doing it, right? Unless it's like life-threatening situations, then probably not. But in the browser, there's not that many life-threatening situations, luckily. So there's a few paths that we can take. I mean, no, sure, when I have nothing on screen, I have to go through everything. But once I have figured out, so this element is this size, and we have like painted it, and all we want to do is change the font color. It's not going to push things around on the page, so we don't have to do the relayouting and figuring out how large things are and where things go. We just have to repaint the text. So we just paint, and then we composite it onto the page, and we'll be happy. Even better, if we're using transformations, and we are like, OK, this is absolutely positioned, so it's not like pushing everything around on the page, and I just want to move it 300 pixels to the right, then that's just the composite page, because we're not changing the elements, we're not pushing things around, so no layout, no paint, and then just composite it onto a different position. That is faster, because we're avoiding work here. So this is how it kind of goes down. Parser goes through, figures out, some CSS object model entries, some DOM elements. OK, here are my elements. I put them onto the page. Then I read from the CSS object model, and I move things around a bit. And then we lay out. And this is like how the layout process looks like. This is taken from Firefox a few years ago, where it kind of like figures out how large the boxes are and kind of figures out how to put them onto the page. And you can see this is a lot of work, right? And if I have to redo it 60 times a second, that's going to be tricky, right? That's not really cool. And then we paint them. So we actually make like the pixels into them, and then we just composite them together, and then we're happy. However, there's JavaScript. That is a party pooper sometimes. Right? So now the layouting work has been done, and we are happy, and we're like, yes, we have made everything, and we have painted everything out, and we are good here. But now, for some reason, JavaScript goes, you know what? That 50% width thing, how about making it larger? And then the browser goes, no. OK, right. So now it pushes things down, and then I run this entire thing again, and now it's larger, so I have to repaint because I don't have enough pixels for making it appear on screen, and like the text looks different now. It doesn't line break there. Ugh, right? That's annoying. It's jerk JavaScript. So let's play a game real quick. So we have a transform here, and this is a translate X for no direction, like no movement, really. It's like the initial state. And then we have a piece of JavaScript that goes, 2,000 milliseconds later, I would like to move that, please, to like 200 pixels to the right. Would that be OK with you? Yeah? Does that paint? Who here thinks it's going to paint? Hands up. Who here thinks it doesn't going to paint? Who here thinks that I should get off stage? OK, fine. It's painting. But Martin, why have you lied to us? You said translation is a composite thing. You are a terrible. Let me go to Twitter and the worst speaker ever. He lied to us on stage. I kind of did, but I kind of didn't, because the thing is, these layers, these sprites, are inexpensive. They cost money, because we have to have a separate array. And if we have 100 DOM elements, and we have a lot of arrays, and a screen is large, especially this one is large and bright. And you don't want to have layers for everything, so you kind of have to figure out how to actually make sensible use of the memory. So the engine goes, the browser goes, wait a minute, I'm not going to make everything a layer, but I make things the layer that makes sense to be a layer. So one thing is the canvas and video elements, because they are, if a video is running, you hopefully get 25 frames per second, so it's constantly repainting anyways. So I'm taking that out and make it into a sprite, because I have to constantly repaint that area anyway. Same with canvas. If you're playing a browser game, it's the same problem. 3D transforms, because 3D transforms are usually popping things out, and you want to use that in composite only, because that's going to be complicated, and especially when you have perspective transformations that you have to run. So we make these but it's a 3D transform. The other one was a 2D transform, so it didn't get created as a layer, so we didn't have composite only. It had to paint, unfortunately. Also composite-only animations, so everything that can theoretically be done in compositing, if it's in an animation, it will definitely be a layer. And then we have the new will change property, which is a more semantic way of telling the browser, by the way, this is going to change. And if that's the case, if that's somewhere, then it's kind of making it into a layer by default. Another round. So here we have a transform again, and we change the amount of movement. Will it paint? Yes? No? It doesn't, because it's a 3D transform. Bam! No green flashing. Good news. If there's green on the screen, that would be bad. There's no green on the screen, we are happy, we have a coffee, and go home. Round 3, here we have an animation that does translate X. Will it paint? Will it not paint? OK? It's a composite-only animation. It's an animation that is a translation. Even though it's a 2D transformation, it is an animation. So it does not paint. I know. Right? It's really? But that's the world we live in. One last thing. Here, I'm animating left. Hold your pitchforks, OK? I know it's a boo-boo, it's a no-no. It's I should not say that ever. Oh my God, how can he do this? You cannot do this. It's not performant. It's not hardware accelerated. It's terrible. You're a really bad person. Actually, no, I'm not, because I'm using will change left. So I tell the browser, hi, browser. So this thing over there, I'm not going to change that. And then the browser goes, right, OK, I can make that as a translation then, and we'll be good. So even the things that are considered bad practices can be turned into good practices using the right tools that the browser and the web platform gives us. So this looks good, doesn't it? I'm really happy about this one. OK, so no green flashing. We are happy. We are fun people. That only works if it's out of the layout flow, because if it pushes the layout around, then we are back to painting again. And so yeah, do not do layout and painting because they are expensive. Compositing is only possible if you have layers. But do not use layers because of using layers. Do not just make it a layer because you can, because it's costly. And it's like copying memory that is not able to fit into the graphics RAM on the phone makes it really, really slow. There's a bunch of signals that the browser uses to figure out if you should create a layer. And there's a website from Paul Lewis and others called CSS Triggers that helps you kind of figure it out, which is kind of nice. And I highly recommend you to not just add on like optimizations, always measure. The DevTools give you the means, and hopefully, thanks to Conrad's amazing work, will give you even better means of figuring out when you're hitting performance bottlenecks because of paint. And if you're like moving something around the page and you see, ooh, there's a lot of green flashing happening, and the DevTools in Chrome can do that, for instance. Firefox is, I think, working on it, I guess. And if you see that, then you can optimize by going into, so how do I make this into a composite-only thing? Only then. Thank you very much.
Wonderful.
The timer over there is red, saying time's up for like 50 minutes now, so I guess we don't have time for questions.
Yeah, sometimes. No, we have a little bit of time. We have a few minutes before the break. To be honest, there was a judgment call made at the back of the room. We just decided to turn your timer to red because we'd heard enough.
Okay, I'm very sorry.
Of course, that's not true. Before we, I'll take a couple of questions if there are any. But before I ask you a question, I've got a question for everyone in the audience. At one point, Martin mentioned that a friend of his was trying to establish a religion that believes in pandas. Can I just ask the room, is there anyone in the room who does not believe in pandas? One person.
What?
One person.
That's the reason.
Okay. All right. Okay. Well, I'm going to show you some photos later that will blow your mind. They really exist. So that was an amazing talk. It's so lovely to have this like level of energy on the third day. I think everyone's really enjoyed that. The ramp up from the start to getting later on was quite severe, I think, with all possible respect. I mean, the first question you asked was, has anyone used a string? And then everyone was OK with that. And then later it got a bit deeper. But I'll take a couple of questions if there are any. But the first question I had for you is, going quite deep into this, and you're looking at a lot of detail, and you're really kind of working hard to squeeze every last drop of performance out of there. But you work on 3D stuff, right? That's where it really matters. For the rest of us, does it really matter? I mean, the browsers are good enough, right?
No, unfortunately not. Like, browsers are amazing and probably the best and most widespread application platform. It's a really good question. Do I even have to care? Yes, unfortunately, you have to care because you might work on a MacBook that is like the latest and greatest, or you might have like a gigantic, wonderful screen with high contrast, and you might sit in a fast internet connection. It's just like with the internet connections, like it loads fast enough on my internet connection, so it's probably going to be okay, right? No, because like half of the world is actually on maximum 3G, if anything, really. So it's the same with performance. If you are seeing a like buttery smooth animation, you're like, ooh, this is amazing, this is nice, and our order form zooms in, and then it like pops out, and wow, and it has like fireworks going on when you order. Great, but if I am on a really old computer or on my phone, and I press a button and it goes stutter, 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 and it turns into a slideshow of dots flying around, I'm like, are you serious? And I'm probably never going to buy again, right? It's like about time and emotion. So measure these things on old devices, especially on old mobile phones, not the latest and greatest devices, and see if they're really performing. And if you see like green flashes all over the place, be sure it's not going to be fast. It just isn't going to be fast. So make sure to measure, 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 and then make it better when you see that there's a problem.
Yeah, very good. And you mentioned like testing on devices, real devices, and a lot of the tools that you are looking at there, I can imagine how I could use those when I'm testing on my laptop. Are there particular techniques and ways that you've been testing on devices to inspect those things?
Yes. So the best thing you can do is Safari has it for iOS devices, Chrome has it for Android devices. What you can do is you can go, like, for instance, on Chrome, it's Chrome://inspect, and plug in your phone, and then you run it on like the page on the actual phone, and you get like the timeline tools and all the paint flashing happening on your phone, but you can see it in your inspector on your computer. So you can do these remote debugging techniques. Safari is catching up there. I hope that Firefox is also catching up there soon. So we are getting there. It's important to do these things. And also just, I mean, if you see that it starts stuttering on the phone, then you know, ooh, there's a problem here. CPU throttling is another way of doing it. Yeah.
Okay, very good. I did spot one particular question on Twitter, but before I go to that, are there any questions in the room? We do have microphones around. We could probably take one, maybe two questions. No? Okay. No, oh, there's a question down here. Can someone find us a microphone? There we go. Gentleman down here.
I love this.
Hi. You said that the wheel change creates a separate layer, even if you use the left property. But the left property could cause a reflow or a repaint, relayout. So how does it cope with the... I'm confused.
That's a very good question, and I find it confusing as well. I actually only found that out a couple of days ago when I was redoing my, I was debugging, and I'm like, how does it work when, so the problem really is, how does it work when it moves and it pushes other things down? It repaints is the answer. If that happens, so if your movement causes other things on the page to move around, it's going to repaint, because it has to do the relayouting, and then it has to repaint, and then it has to recomposite. But if you pop it out of the flow, so for instance, position, I had it on the slide next to it right afterwards. There was a slide with a dragon sitting on top of it again. Can we show the slides one more time? I'll quickly go back. So this is the thing, and here's the slide. It does not happen. It does not work. Will change will not save you if it does trigger relayouts. So do pop it out of the flow, because absolutely position elements do not push everything else around on the page. So that's the way to fix that.
Thank you.
Thank you very much. I think we'll probably draw the questions to a close there. The question that I saw on Twitter often was just people really wanting to hear your Nyan Cat singing again. But I would prefer that. I prefer that would happen out there.
Yeah.
I'm sure if you go and speak to Martin in person, he'd be very happy to do that. So let's have a round of applause, please, for Martin Splitt.
Thank you very much.
Thank you, Martin.